Hot chocolate, red off well. Azure Cosmos Data.
Entity framework, power tools.
Technology suite.
Countdown commencing. T-2 minutes.
Jeremy Lickness.
Shay Rojansky.
Grace Lanson. Martha Vickers.
.NET data. T-1 minute. Thirty seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Hi everyone, we are back again. I am seeing 0 comments. Are you seeing comments, Shay?
I'm seeing 0 comments as well.
So if anybody can actually hear us and see us, please comment. Otherwise, it may look like we're not actually going out there. So assuming we are for the time being, then we have a different kind of stand-up a little bit today.
We got a comment.
Yay! We're going to go over hopefully really quickly because we only have an hour, although like when has that ever been true? And so we have 7 smaller things that we've kind of fixed in EF8 that don't always get a lot of attention, but you know, if they're the thing that you need, it doesn't matter that they're small, they're what you need. And hopefully that some of these things are those things. Some of them are just, oh, that's cool, it'll make life easier for me, which is also good. So we're going to basically go through a list of those things. Before we do that, let's do a quick state of the unicorn. As you might expect, it's the team's fixing critical bugs for GA. We're only able to fix things now that had we shipped, we would service. So we have a servicing bar right now. So we can't fix little things anymore, unfortunately, but we can fix serious issues, which is why it's really important that you try it and report to us, because for about a week, we can still fix issues. After that, you're going to have to wait until the first patch release. So make sure you're trying things out. And in terms of trying things out, RC1 is on NuGet right now. RC2 is going to be on NuGet on October 10th, which has a bunch of bug fixes and some final tweaks to the features. But use the daily builds now. And there's a link, aka .ms ef-daily-builds. It's also on our home, our GitHub homepage. Go get the daily builds. It's super easy. You just put an entry in a NuGet config file and slap it in your folder, and then suddenly your NuGet package field will have the latest and the greatest with all the bug fixes you want. If you try something and on RC1 or RC2 and it fails, either we or you, the next thing we're going to have to do is try it on the daily build anyway. So really just definitely start with the daily builds. It's easier all the way. You will need .NET 8 to use EF Core 8, but the daily builds or the RC1 build and the RC2 build when it comes out of the framework are fine. You don't need to use a daily build of the framework. You can, and that's great for testing the framework, but you don't feel like that's a bit more complicated, so you don't have to go down that path. And remember, we have what's new samples up as usual. So we still have work to do to complete some of those, but there's a lot of things like primitive collections, complex types, and stuff like that that's already in the what's new samples, and we've done stand-ups on them. So go look for those. So that's what's going on. Had I been fully prepared for this, I would have had a slide with what we're actually going to look at today, but I realized I didn't create a slide, so let's do it cheaply here. This is my cheap slide. So these are the 7 things that we're going to try and do quick demos of. So using Sentinels. So this is important when you've got database generated values. If you don't get lost somewhere in the discussion around that, then you're probably not listening hard enough, because the harder you listen to it, the more you'll get lost. No. Massive performance improvements. That's what Shay wrote, so that's what I copied for in and exist. We've seen some of the improvements for in already in terms of the, but there's performance improvements in when we use these things in queries, which is great. DateOnly and TimeOnly SQL Server now. Raw SQL queries for unmapped types doesn't have to be in your model. ExecuteUpdate, as long as the result targets a single table, it will work now. So we'll show you how that makes it more flexible. You can use Numeric SQL Server, numeric properties, typically a ulong, for example, for rowversion, which is easier to deal with, and we've made that easier. And we've done a lot of elimination of parentheses in SQL to make the SQL just generally cleaner. So those are the things we're going to look at. Hopefully we'll get through them all. We'll see. Okay, here we go. So let's talk about Sentinels.
What are Sentinels, Arthur?
I know. Here we go. Let me go back to my notes here. See what I said I was going to start talking about. Okay, so we're not actually going to start talking about Sentinels. We're going to start talking about database default values or default constraints. So on a database column, you can have a default constraint, which says, and that basically says, if I don't provide a value when I'm inserting a row into this table, then for that column, which I haven't provided a value for, generate a default value. And the generated default value can come from a function. So you can see current UTC time, for example, and just have it put a timestamp on it, or it could be a constant value. So you could have a column where a string column and you didn't provide anything, and it would instead provide the string undefined or something in there rather than it just being a null value in the database. So that's database default constraints. Now, people want to use these with EF Core, right? And one of the things, and you could do this with EF6, but one of the problems was in EF6, it was really all or nothing. If you said you wanted to use a default constraint for a column, you could never provide a value through EF. EF would never provide a value, which isn't great, right? Because often you want the default constraint just for the default, but you still want to be able to provide values. And EF6 didn't allow that at all. And one of the problems is, how does EF decide when to send a value and when not to send a value? If you're
like, when is the value absent, right? On your entity.
Writing an insert by hand, you either put a value in or you don't put a value in. It's easy, right? When you're looking at an entity instance, so we've got here user. Am I sharing? Oh no.
No, you're not. Yeah, you need to share.
I will share. Did I share when I was doing the community
the list? No, I thought I actually was asking myself, but you said you hadn't prepared a slide, so I thought the idea was to just do it orally.
You didn't see the unicorn
Nothing at all. I'm sorry. I should have realized this.
Yeah, you're not doing your job. All this was on the screen when I was talking about it.
Sorry. I was
as was my list. But anyway, okay. Now you can see code anyway. It doesn't matter. Let's go for it. Okay, so I've got a user here. So we talked a little bit about default constraints, and the real problem is how do we decide when to insert, when to use the default column constraint and have the database generate a default value, i.e. not insert an explicit value, and when do we insert an explicit value? So let's come back to answer that question using this example. So this example, I've got a very simple model, a user entity, and there's an enum for it. And it's got a few properties on it, and that's it. So there's nothing, nothing complicated there. And none of these, I'm not using database defaults or anything for these at this point. We're just going to insert these into the database without any, there's no default constraints in the databases, there's no default setup, and we're providing a value for everything, okay? So let's run that. And you'll see that in here we have actually a bool value, a bool property, an enum property, and a datetime property in order for us to show various aspects of this. Okay, so created the table, and as you'd expect, we've provided values in the parameters for all of these things. And we've inserted them, and when we get them back, when we pull the data back, the values that we specified are as we would expect. Okay, let us now say we want to create a default column constraint for the lease date. So remember, it was like we want to either provide a lease date, or if one isn't provided, start from immediately, start from right now. So I can do that. I can set that up in EF Core in on model creating by just saying this property has default values equal. So it says, this tells EF, if we don't provide a value for the date, then have the database provide one, and use this for the database to provide it. So let's run this now and see what happens. Actually, did I provide a date for... No, so you can see actually on Toast, I lied earlier, I didn't provide explicit values for all these. You can see for Toast, I haven't actually supplied a lease date, right? So in this case, I haven't changed lease date from whatever its default is. And yet, when we run if we now look at the inserted query, you can see that we haven't inserted for Toast a lease date. And instead, in fact, we've requested it back. So here you see, so it's not in the insert values list, and it is requested back because that's allowed the database to generate, and then we get the value back, and then when we print that out. Now, actually, we know we shouldn't do this, right? We should use UTC, but I'm just going to do datetime now on the one on the client side, and UTC now on the one on the server side, so you can see that the values are getting generated
but you're in the UK. Places. Are they actually going to get different?
Yes, because it's summertime.
Ah, nice. Nice, Arthur.
Daylight saving to the rescue for the once and only time ever.
Everybody hates it, but now it helps.
Yes. So it's 6:13 according to the client, and it's 5:13 on the database, or the other way around, I don't know. So you can see we've now generated the value in the database. But the reason for that is that we saw that this lease date had the CLR default. It hadn't been set, a default date time. And we said, okay, that's the default. So that means it hasn't been set. So, let's use it in the database. And that works really well for something like date time. It works really well for something like nullable values, because the default really isn't a meaningful value, right? Where it doesn't work so well is when the CLR default value is also a value that you might want to insert. So it's like a valid value for the column, but sometimes you still want to not insert a value and use a default constraint. So let's look at how that causes problem. Oh, I should also mention, hopefully, if I've got this right, I'm currently running this on EF7 so that we can see what happens on EF7 first, and then we'll move over to see how it's better on EF8. Okay, so I am going to take now the enum and say, okay, if the enum is if the enum property level is not set to something, then let the database set its default value. So it has default value SQL and has default value have exactly the same semantics. One place you're providing a SQL, the other place you're providing a value, which is kind of nice here because EF will value convert this into the actual database value. So you can actually put the enum thing in here. But the semantics are the same. It still says if it's not set, when we insert it, then use this. Okay, and let's look at what we're inserting. So I've set one to unknown and one to beginner. So they're both set, right? So we should expect this actually not to kick in. But let's see what happens when we run it.
Suspense.
Yes. Okay.
Ooh.
And actually what happened is this one came back as hidden, right? Why is that? Well, because we set level to beginner here. Let's go look. Now, this is bad practice, by the way, for an enum. You shouldn't do this, but just because it's bad practice doesn't mean people don't do it. So the first value in here, had we made that unknown, this would have worked like we'd expected. But because this is the CLR default, it has 0. Its value is 0, basically. When we look at the CLR defaults, we see its beginning. We say, oh, in that case, we're going to use the database default. And that doesn't work because we actually wanted it to insert beginner in this case. And we actually have a value unknown, but because it's not the CLR default, EF isn't using that. And that's where Sentinels come in. So what I'm going to do is go to my project here now. Explorer, let's go to Sentinels. By the way, this is probably the longest one of all the 7. So
yeah, you have to have a lot of background to understand the problem.
This one is solving. Yes. Okay, so we're going to. So I've got the daily builds installed. So I'm using a daily build now of EF Core 8, and I'll just let it restore packages. Okay, and now I have another API I can use here. I can say a Sentinel, and in this I can say has Sentinel level unknown. This changes EF behavior now. So instead of looking for the CLR default, it's going to look for level unknown as a default. And if the level unknown is set, then it's going to use the database default, whatever that might happen to be. And so now what we actually should see is where we, remember, we set one to unknown and one to beginner. And before we got unknown and hidden, now we get hidden and beginner, which I think is exactly what we expected to happen. So that's what Sentinels are for. It's quite an obscure problem. There's one place where lots of people hit it though, and that's with Booleans. Oh, and also I forgot to mention something. We added a nice little thing here, which I should show you real quick before we do the Boolean one. So I've taken the Sentinel off now, so I've gone back to the broken behavior. Okay. We have a warning now. So if you have this, it says the level property level, that might be a bug. That's one of those is supposed to not be level on entity. Oh no, it might be. The enum is called level, and its property is called level on entity type user.
Yeah,
is configured with
message
database.
is a little bit can be tweaked to make it a bit more clear.
Yes, but it actually says here. Like if I can scroll, how can I scroll over in here? I'm missing that. Anyway, you get a warning. It tells you where it is, and we do that for enums and bools. You could have this issue for any other value type. For example, with an integer, if you want a 0 to be a valid value, you might have to set the Sentinel to -1. We don't warn you for those because enums and bools are by far the ones that have the biggest impact here. So let us look at bool for a second. See what goes on there. So in this case, I'm saying for the bool has default value true. So if I don't set any value, then I want EF to insert true into the database.
This is going to be confusing.
Well, what do I mean for a bool to don't set any value? In here, if I set false, that's the CLR value, and if I set true, that's the other value. There is nothing to distinguish between setting one of these values and and not setting one of these values, but it just being that value. And in EF7, this frequently resulted in people getting kind of incorrect behavior. In EF8, it's actually fixed out of the box in the sense that whatever you specify here will now end up in the database if you have a default value constraint on it. So you won't have the case where you set this thing to false, or this thing is false, and then it ends up as true in the database because we treat this as not being set. So if I run this now, and this is running on EF8, remember, you will find that we get true in the one for true that we said was true, and false in the one for false. And the reason that happens is we actually automatically set a sentinel in this one. It's the only place where we automatically set a sentinel, but we basically say if the default is true, then set the sentinel to true, so that it's the same as in the database. But we can't magically invent a new value here, right? So there are still two values. So this still is confusing, right? Because if I now don't set this, if I think that is now not set, whoops, mess up my code. Here we go. That's what I wanted to delete. If that is now not set, it still get false, even though the database default is true, because it's still set to false, right? So it's not a perfect solution. It's just better than it was because the value is the correct value in the database. The value in the database matches the value in the CLR type, which it didn't always before. Okay. We have a nice pattern that actually worked in EF7 to deal with this, and I just want to show it to you because I think not many people know about this. What we could do here was we go to this and we can say to property with backing field. So I haven't changed semantics, just a refactoring. I've got a backing field now. Make this backing field nullable, and then just coalesce on here to false. Okay, so we might want to coalesce to true, given it's our database default, but either way. So what I've got now is I've actually introduced three values here. There's now null, true, and false, where null, it's null if the property hasn't been set. So we're using the ability of CSharp properties as distinct from fields to actually know that there's a difference here. And if we run this, what we find now that because I didn't set the property, instead of it being false, the field, which of course, as you all know, EF uses by default, is null. EF sees it hasn't been set, and so now both are true because the one that's not set really is not set and really does get the database default. So if I were to go and set this back again, for Shay,
I'll wait for you to finish.
If I set this, actually explicitly set this to false now it really will be false because it's not the underlying field is no longer null, it's actually false, and so we know that's been explicitly set to false, and we'll insert it. So I think that's a pretty nice pattern that preserves the semantics and works well. Obviously, it may be overkill for a lot of cases where you can just choose an appropriate sentinel, but if you really need the behavior, it doesn't change your domain model. Like this isn't what we used to scaffold where the whole property was nullable, which works as well and is easier in some respects, but this way you keep the domain model the same, but retain the semantics for whether the property is set or not.
So I just want to make sure people follow this last part. Arthur said this like very, very quickly, but in this kind of case where EF has a backing field, so basically EF sees the isActive property, but it also sees that there's a field, a private field, whose naming matches the property, right? We have this convention kind of thing, and it matches. EF knows, it basically by convention says, okay, these two belong together. That's the field that is backing that property. And to make a long story short, basically what EF now does is it kind of just works with the field, right? And because the field is nullable, it has three states, right? It now has true, false, but also null. And that means that the default, the sentinel, like the default CLR value is no longer false as it was for a normal bool. Instead, it becomes null. So this is this question was actually asked in the chat, so I want to make sure this is good in people's minds. This whole thing that Arthur just talked about, the sentinel problem, basically makes sense mostly only for value types, right? For
Mhm.
reference types in general, the CLR default is null, right? And that just makes sense. That nobody has ever asked themselves, why does EF work? EF work that way. If you have a string is a reference type, and you leave it unset, it will be null. And then when EF sees that it's null, then it's gonna not send it to the database and allow the database default to take effect. So for reference types, everything basically just always worked and everything was fine. The problem was always with value types, and specifically with value types that have values which you're interested in. We do have this kind of problem sometimes with int, because the CLR default for int is 0, and some people want to actually insert a 0, but when they do that, instead they get the database default, because that's again the same problem that Arthur just explained for enum and for bool. You can also do the same thing with int, right? And the trick that you have here, which is to basically just make it nullable, is making the value type into effectively a reference type. So a nullable bool is not a reference type; it's actually a struct, but it is a very special kind of value type that actually is nullable. So the default is null, and that's basically the thing that solves the whole problem. So it's I think we've seen a lot of people run into these issues over the years, right? Like this is a very recurring problem.
It's confusing.
It's confusing, exactly.
Yeah.
It's confusing to anybody. Sometimes we also see people quite confused. So you put a default constraint in the database, and people start to get very confused about who is actually setting what. They expect should EF be sending the correct default, or is it the database? And this whole thing of where the value originates from is very confusing to people, and I think we all understand it, and it is really confusing.
Yeah.
And by the way, in many cases, people set a database default when they don't necessarily need it either, right? If you're setting a database default of 0, for example, you've not done much, right? If you remove that, then EF will start sending zeros when the field is 0, right? So it doesn't really matter if EF sends 0 to the database or the database sets it to 0, because that's the default and EF didn't send anything. So anyway, there's all those kind of related things which are quite confusing when you think about it. But I think in this thing, what Arthur just said, we provide like a much needed kind of way to tweak EF's behavior and to tell it exactly when this, instead of just always use the serial default, you can now define any value as the thing that indicates that the field isn't set, basically, or property.
Yeah. Right. So that was a long one, and we've got 6 more to get through. So if you've got
let's accelerate.
We can still try and answer them at the end.
Absolutely.
This next one is super simple and super quick. And after that, we'll do a query one. So this one is basically just letting everybody know that DateOnly and TimeOnly are now supported in SQL Server, in SQL Client, and therefore we've now built on that support and added them to EF Core SQL Server provider. I put this time span here for a reason that we'll come to in a minute. But basically, if I need to change the one that's running, how do I change the active one from? Maybe I'll just do this. Run. Okay. So we run this one, and let's look at the database that's created. And you can see that date has a date. Date only maps to date. Time only maps to time. Very natural, because that's what the database always had. And we'll do a little query here, so we can see these working. Okay, so adding so I've got a birthday. Makes sense. Birthday to be a date only usually. Most people don't track the minute they were born on their calendar or in their applications or whatever. Shift start is a time of day, and I'm also doing the time span in here and setting that to an 8-hour time span. So we'll save those and then query them back, and it should be exactly as you suspect. There's nothing unusual here. And indeed, we inserted them, and then we queried them back, and we got appropriate values. Now, the only reason I put time span in here is just to remind people that there is no good mapping for time span in SQL Server. So what you may have noticed when we created this database down here, time span also maps to time. And now that we have time only, and you can kind of really see the difference between time span and time only, you can see how this is potentially going to fail. So if I, for example, give Willow a shift length of 25 hours, SQL Server is going to say, you can't do that because there aren't 25 hours in the day, and you've mapped that to a time.
So I do want to
So,
make sure that everybody is aware of the conceptual difference, right, between
yeah,
time only and time span, because up
go
until
for it.
now,
Explain it again.
yeah, there hasn't been a time only thing. So if you wanted to represent, when something starts in the day, you naturally use time span as the way to represent time of day, and that's the way
Yep.
things work because you had nothing else. But basically, time only is a time in the day. It just, it's 8 o'clock, 9 o'clock when something happens in the day relative to the start of the day to midnight. That's a very simple idea. It's basically a number of hours, minutes, seconds, and so on, and smaller particles. Time span is something very different. You can think about it as a time interval. Sometimes that's the word that's used, and it's an arbitrary length. It can be a very long stretch of time. Semantically, it means the duration for for some event, which is very, very different, right? So we used to use time span to indicate the time by the duration from midnight, which was a sort of a hack, but that's not really the thing. And like a good way to really, really drive that home is that obviously you can't have as a time only, you can't have 25 hours, right? You can only have up to
But if I
23
put
hours.
that in here, then that would
Exactly.
throw from C# before we even got anywhere, right?
Exactly. And in fact, time span can
See?
even have a component of days. So you can say a time span of 5 days because
Yeah.
something may last for 5 days. That's not a time, right? That's a completely different thing. So conceptually, it's very daytime in general. Daytime types are among the most confusing and the
Yeah.
most complicated things in general in computers and programming. So it's really worth driving this point home. This is very, very important. Now,
So-
what Arthur is saying, I'm just going to say one small thing here. It's true that SQL Server has nothing to map time span for because there's no idea of an interval inside SQL Server, but other databases do. I just wanted to mention this. So Postgres specifically has something called an interval in the database, and that is exactly what you think it is. There's a slight complication there as well, but we don't have that much time. So basically, an interval is just a duration, and you can add it to a date or to something else, and it's gonna function like you add something with a delta, and then you're going to get the results. And that is a very the perfect way to map a time span from .NET. But unfortunately, SQL Server is limited and doesn't have something like this, so things are not going to work as well. Anyway, that was my segue.
Right, and I think there's a question in the chat about, well, isn't this a problem? Yes, but what else can you map it to? Like, I mean, there isn't actually a good answer to that, right? We could throw, and we've talked about that. We almost did that on EF code, just throw and don't map it to anything. But there are a lot of places where it was useful to map it to a time, and so that felt like it went a bit too far.
Yep.
Yes, date time is way complicated. Okay, let us now move on to improvements we've made for using in instead of exists, which is mostly going to be Shay talking, I think. But I have some queries prepared. So we've got this is Northwind-like model, some customers and orders here, and then I've got some queries, and I will put the first one on, and then let Shay talk about it.
Maybe I'll give a quick intro even before you put the query.
Go for it.
So in EF8, we basically did a lot of work. There's a whole huge feature called primitive collections, right? Which I hope you guys are already aware of. We did a whole session just on that, and there's a blog post on it. So that's one of the major non-small things that are going out in EF Core 8, and I hope that you all benefit from it. But that all actually started by trying to make some improvements to how contains is translated in LINQ. It's actually quite ironic. This is actually, a lot of this was my work, like the thing you just are going to see was my work. And I just started, the whole thing started when I sat down and wanted to solve a very specific performance problem related to contains. And that kind of blew up in the way that, software engineering always blows up. It just always happens into this whole huge feature. And it also there were some offshoots, and this is one of those offshoots of basically making contains better in general. So now maybe you want to show the query on.
Yeah. So I was going to say I'm going to run it on 7 first, and then we will run it on 8 to see the difference.
Mhm.
Okay. So the query here is, well, you want to describe the query? Maybe I should have split it up a bit more, but so
It's
go on.
no problem. So yeah, it's a little bit hard to read. It looks a little bit hard, but the important thing is you see we have the customers and then we have where, and inside that where clause we have something quite complicated, which itself queries the orders of the customers, right? This is the important thing. So when you have something like this, like customers where, and inside that customers orders, that is a subquery. That is basically what we call a subquery, right? Like for each customer, we're gonna look into its orders. That in SQL will translate to a subquery basically. Without even looking at the details, if you look at the subquery underneath, you can already see there's a subquery there, right? Like there's where exists, and then we open parentheses, and we have a nested SQL query. So that already maybe gets you understanding how the LINQ side of things kind of maps or translates into the SQL. But the important thing here, if Arthur, we can go back to the 1 second, just before we
you don't want to
switch
run it yet? Okay.
I just wanted to explain like this very specific thing. So you see the C orders thing, which is the subquery. There's a where on it, where the order region equals region, and then there's a select the name, and at the end of it is a contains operator. So this is exactly the scenario which gets optimized by this specific improvement. So it's when you do a contains in a subquery basically. Right. So what you see, I'm just going to explain the SQL very quickly. What we're basically finding the customers where the orders contain some name. Let's where one of the orders has a certain name, but I'm translating this very loosely. And if you look at the SQL, you see that we select out all customers where exists, where for that customer there exists an order. So we select all the orders for that customer. That's the join that you see there, the where, so on and so forth. And there you see the order region equals region, and then the name equals the name. Okay. So I hopefully that is all clear to people more or less. It's a complicated translation, but anyway, now maybe we should switch to 8 and see what kind of SQL comes out of it.
Did it restore the packages? Don't get overly ambitious and try and run it before it's restored.
Yeah, that can take a while.
Okay. Oh, yep. There we go.
Okay. So something happened. Instead of the exists, where exists, and then a whole subquery, what we now have is where the name is in, and then we open the parentheses. So this is a different SQL syntax where you can say where something is in, and then you can do a whole subquery, right? These are this thing is functionally exactly the same as the last thing that you saw. Modulo some complications which we're not going to go into, which are very complicated behind the scenes. But in this case, everything is completely fine, and the two things are exactly equivalent. So why am I talking about this? What's interesting about this? So it turns out that this form of query, we should actually go to. Yeah. Okay. We should actually go maybe even to the next query to show it even a bit more persuasively.
The next one is the 2 sets.
Yeah, let's do it with 2 sets. You know what?
Okay. Yeah.
I think it's gonna be a bit nicer.
I'll just run this in 8 so we can see the form of it in 8, or do you want me to run it in 7 first?
Maybe switch back to 7 first if possible. Sorry, I want us to have a good example for this.
That's fine. Storing packages. Okay. Should open Notepad or something so we can put them side by side.
Yeah, that would be awesome.
Okay,
that would be really nice.
Here's the 7 translation.
Okay, so you can see that there's an exists, and crucially, the important part, which I want people to notice, is that inside that exists that you see there, we have this where clause over here, which says where the ID is equal to the customer ID. So the important part that I want you guys to notice is that inside that where exists query, we have a reference to something outside that query. That C is something that is not contained within that subquery inside the exists. It's a reference to an external thing. Once it's an external to once it references an external thing, that means that that subquery must be executed for each row, for each customer. We now have to execute that query. So to see which orders of that customer is there, right? That's basically, we call this a correlated subquery in SQL for database people. And people who know what a correlated subquery is already understands why I'm talking about performance, because this is one of the it's one of the major sources of perf problems, because it means that the subquery has to be executed for each and every row, for each and every customer, which is not what we want. However, if we go to 8,
let's see what we do in 8. It's running. Okay, and I'll put this side by side.
Yeah, exactly. So in 8 we have an in. Yeah, I actually, okay. So this query will not actually demonstrate the perf. We didn't, we didn't prepare this exactly correctly, but it doesn't really matter. What I basically want you guys to see, first of all, for these queries, it just uses SQL, which is more natural, right? So it's easier to understand the in part than the exists. It's a more natural way to render our intention or the link thing. Now, there's also a whole class of queries where if you use exists, you're going to end up with a correlated subquery. But if you use the in, the thing is going to be outside. So it's no longer going to be a correlated subquery. That's not the case here. You can see that we still have a CID inside that subquery. So it's still a correlated subquery. But there's a whole class of examples. I should have looked a little bit more with the preparation. It's my fault.
Well, we can try. I've got 2 more queries here, so we can run those and see what we get, right?
We can try. I don't remember anymore. I was looking more for correctness and less for actually showing the performance. So that's on me. I'm sorry.
Okay.
I was sloppy this time. But you can trust me, even if we don't if we don't see it. Trust me. And I'll say a few words about what kind of performance gains we're seeing here, by the way.
Okay, so these are two we had on.
Yeah, that actually looks
that
good.
Last one.
Yeah, look at the very last one there. You can see that in the or at the end, like for example, in the or the one before, exactly. What you see is that inside the parentheses, there's nothing that references anything from the outside. We're only looking at products. But if you run the 7 one, I don't know if you want to run this, Arthur.
Yeah, I'll run this one on 7.
Yeah, let's run it on 7. This is the one we've been looking for, basically.
Packages. Yay.
Right.
Okay, let me put these side by side. We could even fit them side by side because this one's
going to be, it's already a mouthful, right? If we've managed to reduce it, that's already a great thing, by the way.
Yes.
And in general, the shorter your SQL is, there's chances it's also going to be less complicated, and that's actually going to be okay. Oh, I see now that maybe this is also not the right case. Because yeah. Oh, no, it is.
Okay.
But, yeah. Okay. So yeah. Sorry. I'm parsing this in real time, right? So you see the query below has this huge where exists with parentheses.
Yeah.
And inside that you have this where, and at the very end, like the last line there is an o.order ID.
Yeah.
O comes from the outside, making this a correlated subquery.
Yeah.
Right. However, if you look on top, there's no such thing, right? We have a where, and we now have 2 subqueries, right? Two things within. There's 2 subqueries in there. And you can see that the o.product ID and the o.order ID are outside of the parentheses, right? This is exactly the example we were looking for. They're never inside the parentheses. So there's no correlated subquery inside in the first version. What that means, I'm just going to say this, is that the database can evaluate what's inside the parentheses once. Just once. It just does it. It just selects everything because there's no correlation anymore. So it evaluates each of these subqueries once, and then it can do its thing of searching for rows where the product ID is there. That's basically the point here. It turns out that the difference between correlated subqueries and non-correlated subqueries is absolutely humongous. So I did tests in various databases. I'm not going to share my screen here, but you can trust me on this. And if you want, you can go to the issue. I posted all the results. So on MariaDB, for example, like a sample query that I ran in 7 milliseconds. So this is the optimized one. On MariaDB, once again, which is a form of MySQL, right? Let's call it a fork of MySQL. Exists the exact same thing. So we're talking about the same LINQ query running on MariaDB. The exact same LINQ query on EF8 takes 9,800 milliseconds. So it's the difference between 7 milliseconds and 9,000 milliseconds, which is 9 seconds. So that you don't get a more impressive performance optimization.
That's
that
very
is
impressive.
absolutely huge, right? In Postgres, we get a difference between 3 and almost 800. So it's still very, very, very big. On SQLite, we get like another 4-fold kind of thing. But on SQL Server, very surprisingly, we get no optimization at all. So it turns out that SQL Server, I have to give it to SQL Server. I'm not always the biggest fan of SQL Server. I come from the Postgres and I love Postgres and so on. But SQL Server sees through this. When it sees those two SQL queries, it actually sees the same thing. It can optimize away the correlated subquery, and it can evaluate that, execute that query. It can plan for it much better than the other databases. So that's a sort of advantage that SQL Server can handle. Let's call it badly written SQL better than the other databases can.
Badly written SQL that EF Core at least
Exactly.
used to write.
Exactly. So this is
round of applause for SQL Server being
exactly.
the winner for once.
We have to give it its dues. It did a good job here, but the point here is now that if you're using EF Core with any other database, and you happen to be doing a contains over subquery, this is an absolute massive perf increase. Absolutely massive.
Right. Okay, so we've got quite a few more. So moving on to, so when I was doing this morning and I was asking Shay about the queries, which clearly didn't work out as well as we hoped, he said, let's show this too. So so you want to talk about this? So did this even translate in
this specific one did. Some others didn't. I think that you know what? I'm not even sure. That's actually a good question. I'm not even sure.
Well, I'm going to run it in 8 anyway, so we can see what it produces in 8, because I think that's the most interesting thing is what we actually produce for this in 8, right?
No, it didn't. There's no way this ran in 7. No way.
I don't think it did. No.
No.
Okay, so why aren't we seeing? Is that what we're expecting? Oh yes.
Yep, it's pretty good. By the way, this is another example of in. I really did a number on in and contains, as I said, in 8. Like I did a lot of work here.
Yeah.
This couldn't even translate. So if you had 2 parameters, you couldn't check if the ID was one of 2 things. You could do something else. You could extract that array outside into a variable. That's like a hack, right? You could turn it into a variable and then use the variable and do contains on it.
So so let's clarify here, right? So, when we're talking about parameters, right, I and J right now are captured variables in this query, and so they're going to get transformed into parameters. The array itself is not. It's just an inline array. So that's when Shay was saying you could capture the whole array as a parameter, which would do other things. But what we really want to do is just have these be the parameters, and that's what we're doing in EF8.
Exactly. And it turns out that databases optimize for this quite well. So if you have a scenario where you're going to need to check if an ID is one of 2 values, and those 2 values change, like once you're going to run it once and it's going to be 2 and 999, but the next time it's going to be 3 and 5, it doesn't matter, then EF is now going to produce SQL that is exactly the same, but parameterized, meaning that it's going to reuse the query plans. Like it's basically this is the most optimized way to do this, right?
Right.
Now, however, if you don't know if the number of parameters here is not fixed, sometimes it's going to be 2, sometimes it's going to be 3, then this is not the right query for this, right? Yeah. And Arthur, if you want, you can even copy out that thing. We can even do this live if you want.
Yeah.
We don't have to. I mean.
No, I was just wanting to clarify again what you're saying, right? Because I think it's really important, but a little obscure. In this case, when we see this query, it will always have 2 values in that list, right? Exactly. Because this is this doesn't change. This bit doesn't change. The values of these things change, right? So that is different from the case where you want to check for something inside a
An arbitrary
list, right?
Yes.
And that's where if you go back to one of the other sessions and we talked about OpenJSON and all of that stuff, that's where all of that comes in super useful in order to prevent, query pollution and all of those kinds of things we talked about. That's not this case, right? This is not going to pollute the cache, right? Because this is always two values. So we don't want to do any of that OpenJSON stuff, right? We just want to make sure that, we have those two values. So like if I make this, I don't know, if I just extract this out, right?
Exactly. Just extract out.
Even if it's an array, yeah, because an array can have a different number each time.
Yeah,
so
exactly.
I'm gonna have to put it up here, of course. And expression.
There we go.
So now, shall I leave it just like that? That's
good? Yeah, that looks
Yep.
perfect to me.
Right. So now, as far as EF is concerned, even though we know because we're reading this code and everything that it's just, as far as EF is concerned, this could be have a different number of entries in the list each time. And
now you're going to see something very different.
Yeah. So in this case, we get the stuff that we've talked about before on previous stand-up, where we're actually doing OpenJSON on that list, and we're passing the list and passing the whole list, not in two parameters. We're passing the whole list as a single parameter with a list.
Exactly.
Which is not as efficient as the other one, but is much better. In the long term, if you've got variable number of items in the list that you're looking at. Hopefully that was somewhat confusing. Somewhat not confusing.
What I like about this is that if you write your query in a way that gives us the information we need, EF, then we'll translate it for you in a better way. So if you write the new array inside the query, and you put those two variables in it, EF sees it because it's inside the query. So it does whatever it can to translate it in the best way possible. In this case, in the code you're seeing here, EF doesn't know anything. All it knows is that there's a parameterized array. It needs to send an array as a parameter to the database, and that's what it does with the help of JSON. But it cannot do it cannot, or it shouldn't do the thing that you saw before for various reasons. That would not be the right thing.
Yeah.
I'll just say that you can also, so the previous thing where we did a new inside, you can put whatever you want in there. That's like now, again, that we worked a lot on this. You can put, we had two parameters in there, but you can have a parameter, a constant. You can even refer to a column. If you're in a subquery, you can refer to a column on the outside the subquery if you want. So it contains has now become very, very, very flexible. You can do, instead of the J, you can run a function. You can put whatever you want in there, and that's going to translate. So contains really received a lot of love in fact.
Yeah.
That's still one of the simple cases, but it's nice to see it.
So now we have contains with a constant and two parameters.
Exactly.
Beautiful. Okay, let's move on to raw SQL for unmapped types. Did we do raw SQL queries on a stand-up? I kind of half vaguely remember maybe us doing it. I don't know.
I'm not sure anymore. I don't know. Yeah, we should look.
Okay. Well, anyway, we'll go through this fairly quickly, I think. So I've got a simple model with blogs and posts here. Nothing interesting about it. And let's show what we have been able to do for many versions, which is from SQL. So in this case, the scenario here is I want to write my own SQL. We call it raw SQL when you write your own SQL rather than having LINQ create your SQL for you. And traditionally, you can do that for types like posts that are mapped as entity types in the model. So, and you do that by calling from SQL on it. And then you can pass in whatever you want, and we'll execute that SQL and bring back the results. So I've run the wrong one again. Let's run this one in a second. Run. Okay. Now, what we've done in EF8 is allowed you to do this. So you can see that we executed your query for you here, some seeding stuff, and then we executed your query and got back the results just like you wanted. Okay, so what we've done in 8 is allowed you to turn types that are not actually in the model. Okay, so let's say I want to return this blog post, or maybe it'd be better, maybe I call it like a post or something. It doesn't really matter, but it's something that has the shape of a post. It might be a DTO or whatever, but it isn't the actual type that we've got mapped in our model. So we can now do this, and we can have EF query from the post table and populate this unrelated type. And the way we do this is it's similar to from SQL, but it doesn't involve starting from a DB set. So that means it's on database, and it's called SQL query, which we had before for primitive types in EF6 or in EF7, sorry. But now I can do it for non-primitive types, so I can put blog posts in here. And effectively, this is now going to do the same thing it did when I did from SQL, except it's not tracking them because it's not actually creating a model object, but it's bringing back blog posts, and it's matching all of these to the results that came back from the query. So it matches all of the columns and everything, and you end up writing a very simple query to populate these things. This thing also can use mapping attributes, for example. So we can do this. So let's say this thing, the column has is called title, as it is, but we actually want in blog post to call it post title instead. We can do that by adding this attribute, the column attribute, to this, and EF will respect that, and it will now execute a query that brings back title, but then sets post title in the blog post, and the query should look pretty much the same. So that's kind of not very interesting, to be honest. Where it gets a little bit more interesting is where you want to join two tables together and bring back something which is the shape of a combined thing, right? So this is really kind of like now more like a DTO or something, where I just want to send a post summary off somewhere. And so I want to write a query that's going to return these post summaries. But post summaries is not something that's actually in my model. It's just something I'm going to use for a view or something somewhere up there. So if I want to do that, I can write a query that will join on blogs and posts. Put off date there, remove that. So if you'll notice in the post summary, blog name comes from the blog, and post title and published on come from the post. So what I'm doing in my query here is I'm saying select blog name as blog name, so it will match that. So that's another way of, rather than putting a mapping attribute on here, you can actually write queries to bring back the results as whatever property name you have in your unmapped type. Likewise, I'm bringing back the post title as post title and the post published on as published on, joining on that and greater than the cutoff date. And so we can now execute that, and we should get back a whole list. Let me actually run it in the debugger so we can really see that that's what's happening. Okay, so just wait for this to finish. You can do it. Okay, so if you look here, I'm not sure how easy this is to see, but if I look at the summaries, there's 5, and the blog name came from the blog, and the post title came from the post, and so on and so forth. So that's doing exactly what we want it to. Now, one thing that is kind of cool about this is, like from SQL, this, you can compose on this. So here I've got a query which says, okay, bring back post summaries, right? And I've written a raw SQL query that does that, but then I actually want you to use LINQ on top of that to do some further filtering for the published on the published on date. And what we'll see here is this works, right? But it's not as clean as you might like it. So this is the query that we've given to EF, okay? So we don't know anything about this. It's opaque to us, other than we know it returns post summary entities. That's the shape it returns. So we can't modify this to lift the where clause or do anything interesting like that because it's opaque to us. So what we have here is we've got this is the query we supplied to it, look, and we're just using that inside a subquery in terms of for the outer query. Wouldn't it be nicer if we could just generate nice clean SQL from that? Absolutely. And the way you do that is not write your own SQL, but just have EF do what it's always been able to do and project a post summary out of it on a where clause. Like, there's no raw SQL here, and this returns exactly the same thing as the previous query, but because we know all about it and can do appropriate stuff on it, it actually gets optimized into a completely different query than you would get if you do it the other way around. So this is just an example of why, even though, yeah, you can write raw SQL queries and you can compose over it, it's super powerful, but do you really need to write the raw SQL query in the first place, or just use LINQ, where we have more information and so we can do a better job?
This is usually for when EF doesn't do a good job. It does happen, like in some complicated things or some areas of group by or whatever, we still don't do the best job that we could. So yes, and if those places are either there's a bug or we generate SQL that doesn't perform well, that could perform better, then those are good excuses for you to go and write your own SQL. Definitely.
Yeah.
But in other cases, sometimes we see people just doing it for no reason or whatever. I mean, it's fine. You can do that, of course. But usually the idea of using EF is to be using LINQ to express your queries rather than SQL, right? So generally have a good reason for doing this would be the advice.
Yes, indeed. Why is this saying it can't? Oh, because I deleted cutoff date. Never mind. Let me get it back. Okay, so one of the things that I frequently see asks, and I think it's one of those things that is maybe because it's, I didn't mean to do that. Help. Let's exit presentation mode quickly and let me work. Bear with me, please. Okay, let's get rid of that. Go back to presentation mode. Okay. Now we've got. So one of the things that I hear people asking is, how do I call a store procedure? How do I call a function? How do I execute a view? In people's minds, the raw SQL and these things are highly coupled, and the answer is you write the SQL for it, basically. So in my in the model here in the seeder, I created a store procedure called get recent posts and summaries. I created a function, get published posts after, and I created a view. And you can see that I'm calling these by doing select from for the store procedure and for the view and the function, and then the exec for the store procedure. Both of these can be composed upon. So I've got the where clause in here, and that works fine. You can't compose on the store procedure one because SQL doesn't, it's not allowed in SQL, so it's not something that we can support. So for that common question of how do you call those things, that's how you call them, and you can get back your unmapped types. So in fact, you don't even need a model really to be able to execute these things if you don't want to. Okay, let's see. Well, we're over time already.
That's okay.
What's next? What have we not done yet? Oh, let's do your improved execute update and execute delete.
Okay.
Okay, let me find the code.
Yeah, that's
for
kind of
that.
nice.
Here we go. Bulk updates, right. Okay, so simple model. And I don't remember if we start, are we doing this on 7 to start with? I think we might be, so we can see that it doesn't work. Nope, we'll go straight to 8. We'll assume it didn't work on 7. Okay, so hold.
Ooh, a union. That's and a select many. That looks complex.
Well, so it isn't really, right? Because so one of the things that I think, maybe you can talk about this better, Shay, but I think the main thing that you did for execute update is if the end result, the things that the query returns, all map to the same table, then we can do an execute update or an execute delete on them. And that's the point here, is that in EF7 we would not have been able to do that for this, because when we got union, even though both of these return customers, so they're both returning rows in the customer table from a query perspective, we wouldn't have been able to do it because we said, oh, you're using two queries joined together. And
I'm not sure if this is one of the cases which would fail in 7. I don't know.
It was one of the cases listed in the issue.
Oh yeah.
So
interesting.
yeah.
Okay.
This definitely fails in 7, by the way.
Okay, and succeeds in 8 because you're showing it, obviously.
It succeeds in 8. It succeeds in 8 unless you do some other thing, then it fails in 8.
Okay, I see. That's good
All
to
right,
know.
let's run it. Oh, I've run the wrong one again. I'm always doing that. Right, finish that, and now let's run bulk updates. Okay, so you can see that. Oh, did it not run? Oh, should have done. Oh, what am I doing wrong here?
Sorry, I'm answering some questions. I can help you out.
It's weird. It looks like maybe the log got messed up there. I don't know. Let me try running this again. Okay, that's better.
Yeah, weird.
The log got corrupted, which is very weird. So in this case, we do delete from, and then obviously we do the query, which will return customers from the 2 places, and ultimately we're just saying delete them all. So
by the way, this also used to use exists instead of in, the exact same thing, and so was also slower. I'm just gonna throw that, like the previous thing that we talked about.
Okay, so another case where you get to 2 tables, one table rather, but it would fail before, was when you were using table splitting. So for example, an own type. So now I've got customer, and I've said there's an own type, customer info, but we know that actually by default this is going to map to a single table. So I should be able to do something like this. Where I say, okay, execute an update where you set the customer info tag, and also just set the name. In EF7, we would throw saying, you can't do that because these are on different entity types. In EF8, we say, that's fine, we know they're on different entity types, but because they both map to the same table, then we're going to allow this.
Right.
And so you can, if I run it, you'll see that we actually, I mean, it doesn't look that interesting when we run it, right? Because it actually collapses down into a simple thing on the database, and that's why we're able to do it. So
exactly. So the crucial point to understand is that in SQL databases in general, when you do an update or a delete, you can only touch a single table. You can join, by the way, other tables to get information, but in the end, you're only modifying. The target table is just one table, right? And what this change did in EF8 was unlock all the cases where you had something that looks very complicated but happens to actually touch one table at the end. So we kind of unlock those things.
Right.
Is
So
this a bug?
yeah, well, you correct me if I'm wrong. So this will be interesting, right? So I said this works unless you do something else. Well, that something else is table splitting. I believe you recognize that this was a limitation on SQL Server and filed another issue for it. But if it's not, then it's because there's an issue you filed on
Yeah, that's the pruning problem.
the
That's the
pruning
pruning
problem.
problem. I'm
Yeah.
pretty sure.
Yeah, I think it is too. So yes,
But maybe remind me after this show so we're sure that this is debugging in live. This is pretty cool.
Yeah. Well, no, I tried this earlier, and it was like that's what happened. I was like, and then it said table splitting. I thought, oh, I'll move the table splitting and show this one first.
Yeah. Okay, I see.
Okay, and then there's one more interesting case of this, and that's when you're using TPT inheritance mapping. So let us add a
TPT
special.
Or was it TPT or
TPT? Yeah, right. TPT is the only interesting one. I mean, TP8 should have worked anyway, I believe, in 7.
Right, but in TPT you've got different tables for each entity, so that's not going to work. You can't update those.
Yes, you can.
I'm all suspense. I'm like I'm in suspense. I want to see what
for in reality, it all makes sense once you see it. Okay, so what I've done there is I've added special customers that inherit from customers. So I've got an inheritance hierarchy, and I've said this one goes to customers table, this one goes to special customers table. That means TPT, table per type. And then I'm going to execute this query. So what I'm doing here is I'm saying set the set all of these things, right? And is this the one? I think this works. Maybe this one doesn't work and I have to, no, this is the one that doesn't work, right? So this one is saying this can't be translated, right? Because what we're trying to do is set, actually, let's look at the tables. Let's look at the tables. That will make this easier. So what we have is we have a customers table and a special customers table, okay? Now, if you want to update, for example, the name column, that only requires updating the customers table. It doesn't require updating the special customers table. And in fact, customer info that's true as well. So if I run it with 2 of those properties, even though I've got TPT and there is another table involved, this will now work. Right, because I only actually need to do the update on the customers table. And likewise, I can actually say also do this where all I'm doing is updating the note, which is on the special customer. And in this case, it will only update the special customer. But in that first query where I was trying to do things that go across the tables, that wouldn't work. So if in that case, TPC is maybe better, but that depends whether it needs to, might need to update multiple tables for another reason, because the properties do replicate across multiple tables. True. So basically, your best bet is TPH if you really want to do this stuff. But in the cases where you are only going to a single table, then we can do TPT. Yes.
Makes sense.
Okay. Awesome. And we've got 2 really short ones left, I think, now. Is there anything more you wanted to say on the execute update stuff?
Not really. It basically just unlocks some scenarios which were needlessly locked before. So that's some goodness for everybody.
Absolutely. Okay, so let's look at, we've got these really quick. So if you've got any questions, then now would be a good time to ask them. Okay, here's it. It's numeric rowversion. Let me run this. Okay, so a row version, automatic concurrency timestamp in SQL Server is mapped to the database as 8 bytes. It's a binary column with 8 bytes in it. And by default, we're going to map binary columns with 8 bytes to a byte array, which is a reference type where you can mutate the values and do all kinds of things, which really is totally unuseful for an opaque flag like a concurrency token that you're just supposed to copy around and pass. And in fact, is really a pain for concurrency tokens, because you have to make sure that you copy the bytes appropriately and all that kind of stuff. You can't just like copy it around in a normal way, especially if you end up mutating it somewhere, then you can get in a real mess. So given that it's just an opaque 8 bytes, why not map it as a U-long? And so that has been possible in EF for a few versions now. What we did in EF8 is just made it easier. So if you say it's a row version and it's converted to byte array, then we just set this up for you as a row version column in the database, and you can deal with it when you're passing it back and forth and original values and all that good stuff as a U-long, even though in the database it's still the correct row version field. So that's just a nice little, I think, if you do use optimistic concurrency and automatic concurrency in SQL Server, then this is just a slightly nicer pattern to use. I don't see a reason why you wouldn't do it most of the time. Shay?
Do we allow, genuinely asking, do we also allow it without the value converter, like implicitly,
So
like just by saying it's a row
there was a
version?
thing in the issue that said also allow this.
Exactly.
And I implement it, and that doesn't work. And I've got a note to go back and see whether when I was implementing, I realized that was problematic, or I just didn't do that bit of it. I don't know.
Okay.
Because what this does is it still creates a decimal 20 0, and I think you get a warning somewhere
Like a normal
saying,
U-long, yeah.
Yeah, saying that it, yeah, because this is what, there is no U-long in SQL Server, so this is our default value conversion for U-long.
Okay, yeah, could be cool to simplify this even more sometime.
Yeah. And okay, so one final one.
The best one for last.
Yeah,
the
and I don't
absolute
even
best.
know if let me check. I'm going to run this on 7. Yep.
Yeah, that'll be nice.
And I searched in the PR and found the first one where we had 3 parentheses when we started and we didn't have 3 parentheses when we ended. So so when you run this, it's not particularly stellar, example of a query. But it's let me go switch back to the query so you can see the link.
Yeah, those casts are really giving me
But
a
it's
headache.
basically doing a bunch of string concatenation here, and that's caused us to do this with all of these things, which is ugly in itself. But yeah,
I'll just give the context why this looks the way it is. So forget the casts and the coalesces, but when EF generates SQL, this is SQL, right? And when we do plus, then there's the problem of precedence. We have to make sure that the way you write the query in C#, the expression tree that we get gets preserved, that the meaning gets preserved, right? Because operators have precedence. So basically, up to 8, EF tended to just slap parentheses wherever things got hard, so that it could just ignore the problem of parentheses, right? Like a great example is plus, which is an associative, I think is the correct mathematical term. It doesn't really matter, and you don't need to put parentheses at all. You could just it doesn't matter at all whether you do which one you do first. But we still did it, right? As you can see, there's lots of parentheses in that SQL just to make lives easier for us, basically, right? And at the end of the day, let's be clear on this. This doesn't matter that much. This is just about the SQL being nice and readable. So we didn't invest that much in it in previous versions.
Okay,
however,
so let's run it on
in
8. Now we have far fewer parentheses.
Exactly. So this still looks ugly because of all the casts and coalesces, but that's just it could look better depending on which there are some examples where you take something with a huge amount of parentheses and it's awful and you can't read it, and after this it suddenly becomes like amazing and clear. And I do think, stepping back, that this does show a big thing that we have in EF Core, where we also have a goal of generating very tight and very readable and very nice SQL in general, as a general like ideology. This wasn't necessarily the case in EF6. I'm not a big EF6 expert, but usually when you look at EF6, in many cases once it starts getting complicated, there's no way to understand what's going on from the SQL.
The philosophy on the old EF stack was much more, as long as SQL, the SQL engine can execute the query fast, we don't care if it's readable. The philosophy on EF Core, Andrew Peters was pushing this from the beginning, is we need to generate SQL that people can understand, even as well as being fast.
Exactly, and that's important, and I also think that contributes to. I believe people should look at their SQL. So the fact you're using an ORM, you're using LINQ, doesn't mean that SQL is no longer something you should be interested in. In any case where you care about performance and stuff like this, you should be keeping an eye on what the SQL looks like, and we have to help you do that, right? And if the SQL we generate is super hard to parse, you're not going to look at your SQL, and that's gonna yield bad programs basically, and that's not your fault. That's the ORM's fault. So we really do our best. That's, by the way, another thing. When I started looking at the in versus exists thing, it actually started from a readability thing. It makes much more sense to me to express something with where something is in something else, rather than do an exists and then do a join outside. That makes it harder to read. So we're constantly kind of working to try to make the SQL more accessible to you, to the developers. That's important.
Okay, so I haven't been paying attention to the chat at all, so I don't know if there's anything we need to answer, Shay, or whether it's all good. And
it's all good. I've been doing my best. I'm sure I missed some questions, but hopefully nothing too too horrible.
Yeah.
There were some very good questions, by the way. I have to say, and yeah,
excellent. I'll read through them later. I usually read through the log later on just to see what people said. So appreciate your comments. And in 2 weeks' time, we have a very special EF Core community stand-up, and it's also secret. I'm not allowed to tell you about it yet. So
I didn't know this was a secret. But
it's a secret. You know it's a secret. You should know.
Okay.
It's a secret, Shay. Don't tell anyone.
If I didn't know before, now I know.
Yes. So look out for that, because I think that'll be super interesting. And before that, look out for RC2. But of course, you'll all be using the daily bills, so that won't matter too much to any of you, right? So okay, I think that's it. So thank you as always for joining us, and we will see you again next time.
Keep it chargeable.
Keep it chargeable, exactly.